Hello and welcome to this walkthrough of an alkenes exam question which covers quite a range of different aspects of the alkenes topic, its reactions, the electrophilic addition mechanism they undergo, and also some reacting quantities considerations. So let's look at the alkenes reactions section first of all. They want you to complete the flowchart to show the organic product formed in each addition reaction of methyl propene. So the top two should be simple recall. One for hydrogenation, one for bromination. So something along those lines would be appropriate. Different types of structures are fine, so different representations of those same structures would be acceptable. In the bottom one, all you need to do is swap the positions of the H and the Br that's being added across the double bond around, like so. So let's have a quick look at the electrophilic addition mechanism question. So it says that curly arrows are used in reaction mechanisms to show the movement of electron pairs during the reactions, and they want you to use curly arrows to outline the mechanism for the addition reaction of methyl propene with bromine. And the structure of methyl propene has been drawn for you. They want all relevant dipoles in the answer included. So notice I haven't included the product because it hasn't actually been asked for. I've just stuck to dipoles, curly arrows, and lone pairs where appropriate. The next part is a percentage yield calculation. So they first of all want the molecular formula of cyclohexene. So if we look at the structure and carefully consider how many atoms are present at each carbon, there's clearly 6 carbons, but if you add all the hydrogens up, you've got 10 hydrogens, so it's C6H10. So for the percentage yield, the first thing to do is to work out the number of moles of your cyclohexanol that you've used, and that's 0.0765. You need to include the MR of 100 grams per mole in your answer here. It's one of the marking points. So the next thing to do is to think about the equation. So you can see quite clearly the same number of moles on either side. So they're equimolar, as we say. So the expected number of moles of C6H10 would be 0.0765 as well. Now they told us that 0.0268 moles of cyclohexene were obtained. So that's your actual, and the expected is 0.0765. So in these percentage yield calculations, the smaller number always goes on top, bigger number on the bottom. And in this case, that gives you 35%. The next part of the question looks at percentage yield, but also atom economy and some sustainability. So the term atom economy is simply defined by explaining it or putting it as an expression like that. So the MR of the desired product over the total MR of all products in brackets times 100 will be sufficient. And it says cyclohexene can also be prepared by the reaction below. So you can see in this reaction there are no side products. They want you to explain why the atom economy of this cyclohexene preparation is higher than that from before in C. So let's remind ourselves of the preparation in part C using cyclohexanol. You can see that water is a side product. So in the one they're asking us to consider here, there's no waste products as it's an addition reaction. But in the preparation in part C, water is a side product, so that's going to mean the atom economy will be less than 100%. Okay, hopefully this has been a quick whiz through some fairly straightforward questions to do with alkenes. Until next time, thanks for listening and see you soon.